Welcome. In this video, we're integrating the square root of x squared minus 25. And this integral's of the form x squared minus a squared inside of a radical. And when you have an integral of this form, use the substitution x equals a secant theta. In our case, a is equal to 5, since 5 squared will give us the 25 we have in here. So we're letting x equal 5 secant theta, then x squared is equal to 25 secant squared theta, and dx is equal to 5 secant theta tangent theta d theta. Okay, so this becomes the integral, and now wherever I see an x squared, I'm going to go ahead and replace that with 25 secant squared theta. And then wherever I see a dx, I'm going to replace it with 5 times secant theta tangent theta. So rewriting, I get 5 times the square root of 25 times secant squared theta minus 1 times secant theta tangent theta d theta. Now recall that 1 plus tangent squared theta is equal to secant squared theta. So secant, subtracting 1 from both sides, I see that tangent squared theta is equal to secant squared theta minus 1, which is precisely what I have here. So I'm going to replace that with the tangent squared theta. I'm also going to evaluate the square root of 25 as 5 and move that out to the front to have 5 times 5 outside of the integral. So this is 5 squared times the integral of the square root of tangent squared theta times secant theta tangent theta d theta. So I have 25 times the integral of secant theta tangent squared theta d theta. So I'm going to use this previously obtained, so I will be using the previously obtained integral of this from a previous video to rewrite this as 25 times just secant theta tangent theta over 2 minus the natural log of secant theta tangent theta. Excuse me, that should be a sum here, not a product. Divided by 2 plus c. Rewriting further, I end up with 25 over 2. Now, yet again, we need a right triangle. And that's going to help us figure out how to back substitute. What I mean is we started in terms of x's and now we have thetas. We already know what tangent theta is. We already know what secant theta is since we said x equals 5 secant theta. So since x equals 5 secant theta equals x over 5, which tells me that cosine theta equals 5 over x. So the side adjacent to theta is 5. And the hypotenuse of this triangle is x. I'm missing this tall side, this side here. I'm missing this side of this right triangle, and I need that side because I want to back substitute tangent, and tangent is opposite, which is missing. So let's figure that out. Using the Pythagorean theorem, you end up with the square root of x squared minus 25 here. Using that, I see that tangent of theta is equal to the square root of x squared minus 25 divided by 5. So now everywhere I see a secant, I'm going to rewrite x over 5. Everywhere I see a tangent, I'm going to write the square root of x squared minus 25 over 5. So this becomes 25 times 1/2 times secant is x over 5. Tangent of theta is the square root of x squared minus 25. Minus, and then just to make it clear, I should probably make this line a little bit longer. That 2 is under that entire logarithm. So I'm going to write this as 1/2 times the natural log of x over 5 plus the square root of x squared minus 25 over 5. And plus a constant, which I'm going to rewrite, is just C1. If you've been following along with my videos, I think you will already be guessing why I'm changing that to a C1. For the rest of you, hang tight, we'll get there. So this becomes x times the square root of x squared minus 25 divided by 2 minus 25 over 2 times the natural log of x plus the square root of x squared minus 25 minus 25 over 2 times the natural log of 5 plus C1. So I can say C1 minus 25 over 2 ln of 5. I'm going to call that C. So then this final thing just simplifies to x times the square root of x squared minus 25 divided by 2 minus 25 over 2 times the natural log of x plus the square root of x squared minus 25 plus C. Before I close out this video, for those of you wondering what I did from here to here, spend some time reviewing the properties of logarithms. So if you have a over b inside of a logarithm, you can rewrite that as the natural log of a minus the natural log of b. So I hope along with the calculus techniques that you find the brief reviews of algebra and trigonometry helpful.